ROS has good messaging system that uses publisher and subscriber model. My project requires an Arduino to talk to a ROS network. ROS serial for Arduino exists to enable such communication. My previous attempt to use ROS serial on Atmega 168 was not successful due to 1 KB SRAM limit on the Atmega. This time, I will use Atmega 2560 with 8 KB of SRAM. The goal of this post is to go through a setup procedure of a ROS package in order to build and install AVR firmware. I also describe a couple of problems and solutions that I came across during the procedure. ROS packages are built with Catkin build system, which lets me 1. Use a unified system for development of ROS software and Arduino firmware. 2. Avoid using a graphical user interface such as an Arduino IDE, but do all of my development in Vim editor. I plan to use ROS on Raspberry Pi as a controller. Since Raspberry Pi is short on resources, I chose to develop software on a desktop computer. Once the code is more or less in condition for testing on real hardware, I'll sync the required build artifacts to the Raspberry Pi. At this point, ROS Kinetic is already installed in Ubuntu 16.04 VirtualBox that runs on my Mac. I SSH into the VM and ready to go. First, I need to create a ROS workspace, which I named Clobot.ws. The workspace needs to be recreated whenever I switch to a new dev box. Second, I initialize ROS environment. The environment has to be initialized every time I open a new shell. Often I forget to do that, and then I waste my brain cycles to determine what's wrong with the build. Therefore, I wrote a shell function and put it into bash rc so that it gets executed automatically whenever I open a new shell. There is more stuff you can put into that function like I did here. For example, I changed log directory to something I prefer. The function will take me directly to the source code via the command roscd clobot. Of course, the package has to exist first, so now I go ahead and create the package. The tutorial on ROS Wiki instructs to replace the content of cmakelist.txt with their example. Instead, I will keep the auto-generated code for later modifications. For now, I just add the required macros. I use M2560 for the target name, because it's easier to see what firmware I'm building for. Create directory firmware and write the following cmakelist file into it. Also add the following main.cpp file into the same directory. For C++ projects, I prefer the file with function main as main.cpp. It makes it easier to mentally locate the starting point when looking at a new project. Now initiate the build from the Workspace directory. I got an error that ROS Kinetic ROS Serial Arduino and ROS Kinetic ROS Serial packages could not be found. It's simple enough to fix. Let's try again. This time I got a different error. The problem here is that C++ linker cannot find the symbol referring to that function normalize second sec. Okay, let's think. Did I implement all functions? For sure, there were only a couple anyway. Did I link against all required libraries? The tutorial didn't specify anything extra I needed to do, so I'm pretty sure yes, I did. So who calls that function anyway? The error message shows file publisher.h and line 50, but the file doesn't contain any call to normalize second sec. Moreover, there is this global symbol, a global sub I and h. Okay, I need to look at the time.cpp. Who is supposed to build that file? I know nothing about what it has. When I go back to the wiki and double check the example, I see this. So it seems like an oversight. Why the file couldn't be built as part of a ROS library, or alternatively, all the code in time.cpp could be implemented in the header file time.h. The compiler didn't give me any errors, it's only the linker. So who knows? In any case, once I include the file in my CMake lists, the build completes fine. Let's look at the firmware size and make sure we still have room for more code of ours. The field data indicates the amount of used up RAM at compile time, and it's around 29%. We still have around 70% for the runtime. There is still 96% of free space for the program code. Now I upload the firmware. Open 3 console windows. In console 1, I start the ROS core. In console 2, I start a ROS serial node to listen for messages from the Arduino. In console 3, I print the received messages. My console tree shows this. At this point, the results look good enough to me.